Everyone, welcome to another stream. I hope you can hear me really well. I just need to check something. I actually adjusted my settings for this stream recently. I just want to make sure all is okay. So let me just check. All right, so today we'll be starting a new series, okay, where I'll be building the project I told you about. It's amazing how time moves, okay? Just a few weeks ago, we were learning FastAPI together, and now I'm going to start building this project. I don't know how long it will last, okay? But what I can tell you is that I will do it until the end, okay? Until I'm done with it. So, yeah, today is going to be the first part. And of course, before we build, we have to do the system uh, design. Welcome, Linus, to the stream, and happy new month too. Yeah, so I think it's actually right to start on the first of the month. Okay, 1st August, first stream. Okay, so let us start. Okay, so yeah, we're going to start the design. Okay, and of course, the first thing we need to know is the requirements. Okay, we need to know the requirements. So let us start. I just need to make sure I have split my screens correctly so that I can see what is going on in the chat anytime I need to. Okay. So yeah, friends, let's continue. Okay. So the first thing we need to know is the requirements. Okay. The requirements of this app. So let me try to write, and I hope I'll be fast while writing. Okay. So we need to know the requirements. Okay. So, and of course, usually we know that there are two types of requirements. Okay. The functional, okay, and non-functional requirements. Okay, so I can put here functional. Okay, so I'm going to go a little bit slow. So if you're watching this after the stream, you can probably watch at 2x speed. Okay, so we have the functional requirements. Okay, then the non-functional requirements. So non-functional, okay? This is important for us to know about this. And actually, before I give you the requirements, I need to tell you the backstory, okay? How I came up with all this, okay? So it's not just a project I'm building just for YouTube or for just to, okay, to do it on YouTube. No. Early, let me say, since not early, let me say early this year, okay? But to be accurate, I can say starting from last year towards the end, a friend of mine, okay, has begun a company, okay, a travel company where they issue tickets for people, okay, they help them get things like visas, passports, okay, and along the way, this guy became like a co-founder, okay, and became very active together with them, okay, and we've been having this manual process, okay, whereby if someone needs a visa, they reach out to us on either WhatsApp, okay, or come to our office, and we are able to help them get like a visa, okay, like a visit visa, tourist visa, or a passport, okay, or an air ticket, or help them with a yellow fever card, okay, maybe refer them to a labor company, things like that, okay. And this has been happening for quite, I think now almost a year and some month, okay, maybe 4 months. And now we want now to scale it, okay. And one of the ways to do it is by having a system, okay. Of course, when people come to our office, or when we book for people using our via WhatsApp, what happens is that we have systems, okay. I mean, we have heard about systems like Amadeus, etc. Okay, we have systems, okay, that we use for verifying, checking the prices of tickets and all the things, okay. And actually, I forgot to tell you that my colleagues actually did an aviation course, okay. They did an aviation course and excelled at it very well, and they worked with an airline in the past, okay. And they are working on something called IATA. I don't know if you guys know IATA. They did IATA. If I can quickly Google it for you here. IATA, okay? IATA, it's the International Airport International Air Transport Association. Okay, they did IATA and passed it very well. Okay, so yeah, that's the backstory. So we are going to build an application to help facilitate that. Okay, and I'm going to do it live. Okay, and I try to complete as much as possible, at least the MVP live. Okay, whereby it can be functional and you guys can also learn from it. Okay, as I also learn. Okay, because like I learned FastAPI in public with you, and uh I'm now trying to master FastAPI by building the project. Okay, so this is going to be a real world project. So whenever you see me doing any mistake, okay, please let me know. Okay, because it can be costly if it goes to production. Okay, so yeah, we're going to continue learning and cementing all the things that we learned. Okay, in depth. Okay, starting today. So like I told you, the first step is to know the requirements. Okay, of this application. And of course, we have the functional requirements and non-functional requirements. Okay. So the first functional requirement is that we need to be able to search flights. Okay. So a functional requirement is simply what the app should do. Okay. How the app should do as seen from the user's side. Okay. So the first thing is to search a flight. Okay. And of course, when you're searching a flight, you know that you have to search by like the origin, okay? Where the origin, the destination, the date, okay? The passengers. You need to specify whether it is a return trip, okay? A round trip, meaning you're going and coming back, or it's only direct and one way, okay? Then, after of course searching, you need to view, okay? You need to view the flight details, okay? You need to view the flight details. Okay, so I'm going to try to type fast. You need to view the flight details. Okay, after you've done with viewing the flight details, the next thing that needs to happen is one of the things we need is authentication. Okay, user authentication. So at some point we need to book. Okay, and before you book a flight, at least you need to either log in or sign up. Okay, so we need user authentication. Okay, what else do we need? We need Giant says super excited. That's good to know. I'm also very excited about this. After that, another function requirement we need to issue a ticket. Okay, so I can say ticket issuance. I hope you get. I don't know if my handwriting is not okay. Forgive me. I hope you can understand what I'm writing. Ticket issuance. Okay, we need to issue tickets. Okay, after you've booked, then maybe one other thing that is important, maybe seat selection. Okay, we need to add seat selection. Oh my god, I'm thinking about this makes me wonder how the front end will do this. Okay, this is the most challenging thing I think in this project for the front end. Okay, being able to implement the seat map, but we shall see that. Okay, and solve it together. Then maybe booking history. Okay, the booking history. Okay, yeah, so for now maybe I can list only this, but of course the other requirements. Okay, so I'm assuming this was an interview and they're asking me to design. Okay, this is what I would do. Okay, so the function requirements this, and maybe yeah, so maybe the non-functional, I would say there has to be high availability. Okay, there has to be very high availability. That would be the first. Let me first check my screen here to make sure you guys can see properly. Okay, so there has to be high availability. Then it says, what about if I want to cancel a flight or update details or pay for the flight? Okay, so we're going to talk about, yes, actually that is correct. Okay, we need payment. Okay, I'll say payment. We need to pay. Okay, we need payment. Okay, need pay. Okay, you need to, let me see, cancel a flight to update. Yes, you need to cancel. That's correct. Cancel flight. Okay. Yeah, this is good. So after that, like I was going to the non-functional requirements. We need high availability. Okay. Looks like writing A is becoming a problem. Okay. So we need really high availability. Okay. So I'll just say high available. Okay, to save time. Then what else? We need, in case maybe this application, okay, grows, okay, and it's very big, okay, I need this application to be able to scale, okay. So imagine like maybe today, suddenly maybe today we have 10,000 users or 100,000 users. We need it to scale, okay, and immediately if maybe like users reduce, okay, maybe like to from 10,000 to maybe 500 or to only 10 users, okay, we need it to scale down. So to easily scale up and scale down. So the other non-functional requirement is scalability. Okay. Especially in terms of searches. Okay. When searching can be a very serious task. Okay. In case millions of users as their real-time, okay, searches, then we need something like low latency. Okay. Especially when you're searching. Okay. When you search for, it should be low latency when you're searching for a flight. Okay. So I'll say low latency, okay? And this is for search, okay? Maybe here, you can say maybe in brackets so that we can track this, okay? In case maybe when we are coding and we are, say maybe million, okay? Maybe like we have millions of users. When you have millions of users, okay, I see the chat popping up. Giant says, do we use Kubernetes for scalability? Like to increase pods or something like that. Yeah, we're going to talk about actually Kubernetes. In this project, you'll have to use Kubernetes and Docker, okay? So Kubernetes will be like the orchestrator, okay? Like to increase the number of instances of our stuff, of our application. Yeah, so we're going to use Kubernetes, Giant. What else? What else? Okay. What else? What else? Because let me see what else. What's a good non-functional requirement? Consistency, okay? Just be consistent actually, okay? Yeah, just be consistent. So I'm trying to, right now I'm trying to decide in my mind between the word consistent, consistence and consistence, which one is shorter, okay? Okay, consistency, okay? In case of like booking, okay? This is in the case of booking, okay? You want booking to always be consistent. Things like booking, cancellation of tickets, okay, updating, okay, you need consistency, okay, even when you're issuing the ticket, okay, when you're doing ticketing, it must be correct, okay. So case of ticketing, I'll have that. Then of course we need to rely on it, okay. In case of maybe like there's a network failure, in case like there's maybe an API failure, okay, needs to be resilient. You need to rely on it, and this needs to be resilient. Okay. I see the chat popping up. Lena says, "How about trust that users should have on the platform?" Yes, they should be able to trust. Okay, but when you're talking about non-functional requirements, you need to you need to you talk about requirements in regard to how a system should operate. Okay, yeah. So maybe trust is something we can maybe put maybe decide, maybe integrity, okay? Can just say maybe integrity. I can put trust under integrity, okay? Because at least you can define integrity in terms of operation, okay? And we shall talk about that when we're developing the real thing. Okay, yeah. So this is it for now. Okay. So let me see. Okay. So I hope this is still, I've tried to zoom out. So I hope you can all still see this. Okay. So these are the requirements, the functional requirements, together with the non-functional requirements. Ajahn says yes, fallbacks and rollbacks for resilience. Yeah, exactly. Okay. Yeah, nice catch. For example, like let us say maybe we did an operation, okay, and probably maybe we were deleting, okay, or we were updating maybe a ticket, okay, or someone maybe was making payment, okay, but the transaction for some reason was maybe not successful, okay, and after that something else was supposed to happen, okay. All those transactions a transaction ideally the whole goal should be this, okay. A transaction a group of transactions for a particular user should either all happen or not happen, okay. So in case maybe things go wrong, we should be able to roll back, okay. Yeah, we should be able to roll back transactions. And the answer is acid properties. Yes, that's correct. And I love the A, okay, called the atomicity, okay. I love the A in acid, okay. So here we shall have rollbacks and stuff like that, okay. Rollbacks and fallbacks, okay. So it's a lot of stuff to do if you think about it, okay. Yeah, but I'm going to do my best and we see how far we can go, okay. At least the MVP should be ready by the end of this series, okay. Now, next up, I want to go to the high level architecture, okay, since we are done with the functional requirements. So the high level architecture, okay. So what will this look like? What do you think? Type in the chat. What would the high level architecture be like? And also, please let me know. I changed the settings for my stream, okay. When we were streaming previously, when we were learning FastAPI, the latency setting on YouTube was normal, okay? But this time I decided to choose low latency, okay? And I'm not really sure about the internet, okay? Like those of you who are in Africa, you know our internet is kind of shaky. Please let me know in the chat how the internet is and how the video quality is, because I might be seeing it okay on my end and yet you can't see. Let me try to refresh this screen. Okay, in case it drops, please let me know. Okay, so let's continue. Okay, let's continue, but please let me know. Okay. Okay, so the high level architecture. Okay, so of course you know it's going to be a client server kind of communication, right? Okay, but the clients ideally, I want to be specific, okay, will be web or mobile, okay, like a mobile device, okay, a phone, tablet, okay, or things like uh, your laptop, your desktop, okay? And of course, in my definition of a client, I think a client is simply an entity on the internet, okay, or in a network which sends a request to a server, okay, and which means it can be an API, okay. An API can send a request to another API, okay. But for now, I'm not including APIs, okay. I cannot include APIs. Okay, I'm not including APIs as my client. So I want to only have web devices that on the web platform, okay, and devices on the mobile, okay. So maybe if this when this becomes maybe very successful, okay, and maybe there's a community of developers who want to build on top, okay, of this whole system, that's when maybe I can create APIs for them, okay. But for now, this is simply client, okay. Then, of course, they'll send requests, okay? But ideally, for now, okay, in my mind, I'm thinking of having an API gateway, okay? And we shall configure all this, okay? API gateway, API gateway, okay? Agent says internet is fine. It's streaming good. Thank you for letting me know. API gateway. So my goal of this stream is for us to like I showed you earlier, okay? Learning a tool, okay? We learned FastAPI, and then after that, we are building a whole backend and the DevOps to the end, including the front end, okay? So that yeah, I learn, but you also learn, okay? And we know what to do. So in case of any insights, like Giant and Linus have been typing in the chat, please don't hesitate. Okay. And don't fear, by the way, guys. One thing I know about life is that anyone can learn anything from anybody. Okay. So what will this API gateway do? Maybe later, maybe at the advanced stage, okay, it should be maybe for things like rate limiting, okay. But even this we can do it on our application, okay. But the whole goal would be rate limiting, okay. When I reach that level, okay, rate limiting, okay, even you can do auth here, okay, okay. But primarily, what I want to use this load balancer for, or the very first case when I'll be, I mean, not use the load, but use the API gateways for load balancing, okay. But of course, the load balancing, like you had Jayat talking about, okay, Kubernetes, okay. Kubernetes can help you with that kind of stuff, okay. So you might find that maybe we don't need that, okay. Kubernetes can help us for scaling, okay. So so then after that, we have now our actual backend, okay. So in the beginning, okay, we are going to start with a monolith, okay. Going to start with a monolith, and if maybe later there's need for something like what is it called, like a microservice, okay, then we can have a number of backend services, okay. But ideally for the backend, okay, we're going to have stuff like a search service, okay, in our setup, okay. Just follow the functional requirements, okay. We just say backend services, okay. So something like a search service, of course, the book service, which handles everything concerning booking, okay. We shall have the payment, okay, to handle everything concerning payment, okay. Then, by the way, there's something I forgot. If you remember, okay, we need something for notifications, okay. We need a notification service, okay. This one is should be there. People need to know when the ticket has been issued, because usually when you book a ticket, it can take some time to be issued, okay. Or when like maybe a reminder for check-in, reminder for, I don't know, anything, okay. Then maybe also the one for managing users, we need a service for managing users, okay. Then even things for like seat management, okay. Can I say inventory? Okay, something like inventory. Let me just say seat management, something like that, okay. So we're going to learn all this together. The answer is sign up, sign in. Yes, that is under users, okay. So yeah, users, user service / auth, okay. Okay, so after this, okay, and of course, as we are building, as we build the application, we shall keep on, how can I call it? Now, shall keep on iterating, okay. So this is what I'm saying. In case you anything comes to your mind, let me know, okay. Let me know. Okay, then after that, we need databases. Of course, the database, okay. That one is obvious, okay. Connect this connected to the database, okay. So I can say databases, so, or external systems, okay. If you're going to have external systems, so external systems, okay. For external systems, okay, I am going to use a third party, okay. Because all these services, okay, have to, like, for example, like the booking, if we were looking at maybe a microservice, okay, ideally the booking service would interact with the booking database, okay. The inventory or seat management would work with the inventory database. The user or authentication service would work with the user DB, okay, like that, okay. But for now, like I was saying, we're going to have a monolith, okay, I'll just assume we have one database for the beginning. Okay. We have one database. Okay. Then something, the external service we shall need a payment gateway. Okay. And being in Africa or East Africa, I might have to install, to do something like mobile money or and card. Okay. So we need a payment gateway. This is an area where we shall do research together. And yeah, it will be nice doing that. Then we need third-party APIs. Okay. Third-party API. And the one I want to use is called Amadeus. Okay. So at my company that I told you about, we use Amadeus and something called Travelport. Okay. So if I open this tab and I Google what's Amadeus self-service APIs. Okay, something I was checking out. So if I come here, so guys, are you enjoying this so far? If you look at this, okay, let me expand it so that you can read. Okay, and I scroll. They say the Amadeus self-service catalog is a curated selection of APIs covering the entire travel cycle: inspiration, travel search, travel booking, transfers, in destination. Okay, the self-service catalog is a comprised of 6 categories. Okay, flight APIs, flight search, booking, airport information, cars, okay, hotels. Okay, but our goal will be to do this first one. Okay. Okay, so you get it. Okay, so yeah, this is the goal, to do this flight booking. Okay, offers each of these is very important. Okay, then after that, there are things like when you come to inspiration. Okay, there's some which flight schedule. Okay, these are airlines. Okay, we shall see them one by one. Okay, and actually it will be very enjoyable, and actually it's very easy to implement these things, like we shall see. All right, thank you, Jayat, for letting me know it's going great. Okay, I would love to know what the others think so far. Okay, so after this, so this is like the high level. Okay, this is the high level architecture. Wow, this I've over zoomed out. Okay, so if I now go to the component design, okay, so we have talked about the functional requirements and non-functional requirements. Okay, we have now gone to the high level architecture. Let's now talk about if I can use a different color, the component design. Okay, so I'm going through this so that when I'm creating the actual project, okay, and I get lost, okay, even you can help me. Okay, because this is going to be live. Okay, I'll be making mistakes. Okay, in fact, like today I was trying to search on the internet, how do you live stream without sharing like secrets? Because I'm imagining we are on AWS. Okay, then I'm sharing a secret, and I learned about a way. Okay, because if I share secret live, you might see in AWS closing me out. Okay, because one time I made a mistake. I pushed a key, a secret key to my GitHub the first time I was learning AWS, and I just discovered AWS sending me emails and what, things failing. It was crazy. Okay. Yeah. So I'll fail. And if I fail, you guys will help me to learn. Okay. So component design. Okay. So the first thing that is, I think, critical to this application, if you think about it, okay, is the search service. Okay. Let's talk about the search service. Okay. Which color was I using earlier? Okay. The search service. Okay. Very, very important. Okay. This one will either kill or make the backend, because searching is very read heavy. Okay. Making API calls every time you search. Alana says, yes, I'm learning a lot all the way from backstory to the high level architecture. That's good to know. So this component A is the search service. Now the search service, okay, ideally has to read, okay, read, or maybe just get data, okay? Fetch, okay? Let me say fetch from the external API, okay? Which is Amadeus, okay? So it just fetch from Amadeus ideally, okay? But you have to take note of this, okay? Amadeus is going to charge me for hitting their endpoints, okay? So ideally, what should happen is this, okay? If a search is similar, okay, maybe you search for the same thing. Maybe you search and say, I am maybe Nehemiah. I want to go to Nairobi or maybe to India. Okay, Nehemiah, I want to go to India tomorrow. Okay, and I search for that information in a span of maybe, let me say, 5 to 15 minutes. Okay, I should be able. Okay, I should be able um to get the same result, okay, without hitting the API. So which means, okay, I should, there are two things that should come from this, okay? When I'm fetching, okay, I need to put some things in a temporary cache, a caching layer, okay? I need to cache, okay, a caching layer, okay? And for this, I'm going to use Redis, okay? So you're going to see that I will run, as the project grows, I'm going to run Redis in Docker, okay? Via Docker, we shall run Redis, okay? So I'll say Redis, okay? Redis is going to be our caching layer, okay? Another way is maybe to save some of the user searches, okay, to the database. We can save some of them, okay? Maybe we can ask a user if they want to opt into such things, okay? So you can either search maybe like the database, okay, and avoid hitting the Amadeus API, okay, to save on some money, okay? But I think the best thing would be to search, okay? I don't know what you guys think. I'm trying to think about the trade-offs, okay? But so, and also caching is also very critical, because if you cache, for example, like for 1 hour, but then the flight information changes, then the user will get old data, okay? So what they call stale data, okay? The information will be stale. So you do not want to give the information that is stale to the user, okay? You'd want to give them what is fresh. So maybe the cache can be like for 5 minutes to 15, okay? Okay, just getting the chat. Giant says the bouncing can be implemented in such service for robust implementation. Yeah, you can also do the bouncing, okay? It can help you to avoid frequent executing, okay? Come on, okay? Just put here the bounce, okay? These are all techniques that you can have to have something that is performant. You see, I'm loving this, okay? Then, so ideally we read from Redis first, okay, in case there's something in the cache. Otherwise, maybe you go and yeah, you give you make a request to the Amadeus API, okay, and of course for every we need things like rate limiting, okay. If you remember the API gateway, okay, rate limit. Do not people to just come and make our thing fail by making millions of requests, okay, and they overwhelm our application because of lack of resources, okay. Then for the search service, the tech, if you talk about the tech, when I'm talking about tech is because I don't know if you guys know about something called a full text search, okay. I'm thinking if maybe this project grows, okay, and is very now popular and has many users, okay, we need full text search, okay. And one of the popular tools of full text search is called Elasticsearch, okay. I don't know if you guys have heard about Elasticsearch, okay. And I've also recently I've heard about a technique called denormalizing, where you denormalize your database tables to help you with better search, okay. So I want to Google Elasticsearch, okay. So you see this here, it says Elasticsearch is a source available search engine. It is based on Apache Lucene and provides a distributed multi-tenant capable full text search engine with an HTTP, okay? Simply modern way of searching, okay? That's the best way I can talk about it, okay? So we shall need a full text search, okay? So this is for the search service, okay? Let's go, okay? Ideally, this would be microservices, but we're going to start with a monolith, okay? And why not? Recently, there was a popular story on the internet, okay, of guys who migrated from a monolith to, from microservices to monolith, but I forget why they did that, okay. Hey, and by the for this, another technique we can do, okay, to improve the search, okay, is indexing, okay. If we are storing some information in the database, okay, we can use indexing techniques, okay. Like we can pre-index and auto suggest, okay. It can help. It's a good way to optimize, okay. So there are several techniques: caching, indexing, and full text search, okay. All right, so the next one is maybe seat management, okay, inventory and seat management, okay. Thinking about the UI, I wonder how people create that stuff, okay, but we shall learn it together, okay, when we reach the Next.js part. So for the seat service, okay, you need to be able, of course, to manage. The whole goal is to manage the number of seats, okay, per flight, okay. What the major challenge I'm thinking about here is concurrency, okay, managing concurrency control. This one is very, very key, okay. So just to check the screen and the okay, that's okay. Concurrency control. So we can look at for this, by the way, we can do some kind of locking, okay. This is a technique I read about called optimistic locking. I've never read about it. I'll just need to learn about it. I need to discover if the Amadeus API does this. Okay. I've also heard about something called Redis locks. Okay. We can do Redis locks to help us to prevent overbooking. I'm not sure. I've not known how to use it. We shall have to learn about it together. Redis locks. Okay. Giant says will we be using WebSockets for seat management? I'm not sure, to be honest. But you can tell me how you think a WebSocket can help us with seat management. Okay. But it will be actually real time. I think it can help. Since WebSocket is a full duplex stuff, and it can give us that real time stuff whereby you click like this and you have your seat taken. Okay. It is faster by than having HTTP REST API endpoint being hid and then that whole slow stuff. I guess it can help. I see the point of using a WebSocket. Yeah, good one, Giant. And when we're implementing, please remind me, okay? So ideally, let me try to do this, okay? This way a WebSocket can come in, okay, to help, okay? Or Gambo G says maybe for each plane. So you mean like per airline, we have like a socket, like a WebSocket for each airline? Is that what you mean, Gembo G? But guys, forgive me if I mispronounce your names. So, seat management for storing data. Okay, he has confirmed. Yeah, it can help. Okay, and again, when we reach the implementation, we shall have to think out loud and carefully on how the WebSocket can help us. Whereby we can say maybe for each airline, okay, we have a WebSocket connection for only that one. Okay, yeah, that's actually wise. That can help. For this, I'm not thinking of the data. I'm not thinking of us storing this because ideally it's the Amadeus guys who have this information. Okay, I'm not thinking of us. Oh, by the way, guys, if you think about it, the seat management, we're going to be calling an API to help us with seat management. I don't think it's a WebSocket, guys. If we go to Amadeus, hey, this is going to be interesting. Unless maybe we have on our end, we have a WebSocket from the front end to us is a WebSocket, but Amadeus, I don't think it is. So I don't know where their thing for flight seat map display. Okay, you see they have this seat map display. So if I come here, it says create an account, get installed. It says seat map display API allows you to get information and display airplane cabin plan from a flight offer in order for the traveler to be able to choose his seat during his flight booking. During the flight booking flow, thanks to post method. You see, once you see post method, just know this is REST. Okay, and I say in addition, get method allows you to display airline cabin plan from an existing flight order. So if we, so ideally, the order is simply saying you can do a get request to get the plan of the cabin. Okay, then someone can choose the seat by doing a post to the same endpoint. So post, choosing a seat, get to see the seat display. So my brothers, my friends, are we not in trouble? Jayat and Ogem, what do you think? There's no cool REST API. Okay, so if I come with the API reference and examples, I hope they don't ask me to sign in because I don't want to do it now. So you see, this is the base URL, test.api amadeus.com v1. Okay, and here you see, I told it's a REST API. So this is their documentation. So it returns all the seat maps of a given order. Okay, so it has the flight order ID, which is a string, the flight order ID, that, and they give an example. Okay, and then it's the response. Okay, this is the data we get. So we have to actually render it on the front end. So I told this is going to be interesting to implement on the front end. If we fail, guys, we shall call OpenAI. Tell AI, save our job. And then you have this other one. See, post returns all the seat maps of a given. Let us see. They say it returns, but what's the body? So these all return simply, okay, and help you to choose. So I think you get it, okay. Then you say, okay, then polling can be used. Ideally, if we wanted like for what I'm trying to say that the actual WebSocket, okay, or polling should be implemented by these guys, okay, like this. They should be having like a WebSocket, an endpoint, okay, that helps that has a WebSocket implementation on their end, okay. But what we can do on our end, we can also have we can have a WebSocket, okay, but this WebSocket sends information to our backend, but under the hood, we shall still make requests to these REST endpoints, okay. So whether we implement polling or WebSocket, still we have to execute these endpoints. Okay. I don't know if that makes sense. All right. So here we're not storing it in the data. Okay. So next up, the other component. Okay. Let me pick another color so we alternate. Component C. Okay. Component C will be the booking. Okay. The booking service. And I think for the booking service, we shall need to store information. Okay. We have the booking service. Ogembo, you're saying it does. What do you mean it does? Do you mean like the Amadeus API has a WebSocket? Jan says they've understood. That is good to know. So let's go on the next service. Okay. So those who are just joining right now, we began by defining the requirements. Okay, I told everybody the backstory. Okay, you can watch like the first 5 minutes of this stream after it is done to understand the backstory. We talked about the requirements, the functional and non-functional. We went to the high level architecture. Okay, after the high level architecture, we're now looking at the component design. We have looked at the search service. We looked at the seat management service. Now we're now on the booking service. The actual process of booking, right? I would say you select a seat, okay? If you use an airline, I think it's the same everywhere, okay? You simply after doing all that information, okay? After you search, okay, view results, okay? When you're done, you select your seat, okay? After selecting your seat, what else? It's payment, okay? We need payment to be processed, okay? The whole idea flow will be you process payment, okay? And like I mentioned earlier, this will now go to the external API for payment, okay? So if a person chooses mobile money, we use mobile money. If it is card, we use card, okay? You process payment, okay? After processing payment, okay, you have to confirm booking. Now there's a common one which I used to hear about in the software development industry. And I would wonder, what's this, okay? It's called idempotent, okay? This has to be, we need to have, let me Google, because English is not my language. And I show you what the Google idempotent, okay? So it says denoting a set of denoting an element of a set which is unchanged in value, okay? So in this case, we need idempotent APIs, meaning they should do the same thing, okay? In the event that maybe an endpoint is hit, okay, at any time, the result should always be the same. It should do the same thing. Okay. So we need idempotent APIs. Okay. In case of like retries, okay, when a retry is done, okay, we need the APIs to be, I hope it's how they pronounce it. Okay. Idempotent. Like that. Okay. Idempotent API. It should be an idempotent API. Okay. Why? Because we may need to handle retries. Okay. I'm not yet sure, but we shall see how we implement this. And actually, by the way, when I'll do the MVP, I'll give it to my colleagues and some of my clients to like a private beta to test, okay? And we get feedback. I want the feedback to come from real people in the real world, okay? Select payment. Yeah, it says select payment. Select seat, make payment, okay? Seat confirmed. Yes. Yeah, this is the actual flow, ideally. Thank you. So I'm thinking about handling transaction. There's something I've heard about, but I've never used it. Okay. Is it called, is it Saga? I don't know if I remember properly. Okay. Saga pattern. Saga pattern is a design pattern used in distributed systems to manage data consistency across multiple microservices. Okay. Maybe this can come in later, but for now, like I told you, we're going to start with a monolith. Okay. What other thing do we need to talk about? Go back to white. Okay. We need to talk about which service, okay? Maybe payment, okay? The payment service, okay? It's going to be nice implementing all this, okay? So at the end of this, after we are done with this, we shall now go to just basic project setup, okay? And of course, you guys will advise me either we follow what we learned about when we're learning or something else, okay? So this one I think is pretty obvious, okay? We need to just simply integrate with external APIs, okay? Integrate with things like Stripe and whatever. But I don't think Stripe works because I want my applications to start working like maybe Africa at least properly. Okay. I'm not sure if Stripe, because in my country Stripe is not supported. Okay. So maybe I just need to maybe integrate like some kind of like, I don't know, local API. There's something, is it called Flutterwave? I've never used it, but I've had people talk about it. Okay. So Yeah, you just need to integrate an API for payment. Okay. Ogembo says Chimoni. Is that a payment gateway? Let me Google it. Seamless cross-border payments. Oh, thank you. Again, let me Google it. Payout issue wallets in 100 plus countries. Okay. Okay, this is nice. So yeah, I'll check it out. Log into Chimoni. Let me. How good is it, Ogembo? Please let me know about this payment. How in your experience, I mean, how have you seen this? Let me go to the developer kit. If I come here to, I want to paste it here. Okay. It is here. Wow. I need to copy. Come here and expand it. Okay, like this Chimoni, so that later I can refer to this document. This way, I like doing things in public. Okay, you get to learn from other people. Developer toolkit, you get way to, okay, integration guides. Let me look at their use cases, what they could be having. So they have e-commerce and retail, corporate, financial services. Okay, this is something I need to look at in detail later. Okay, so let me first close it. I'll study it later. Okay, let's close this. Let's continue. So what else? Of course, here, but this one is very critical. Okay, concerning handling things like success and failure. Okay, thinking about implementing. Every time I implement payment, guys, I feel like getting a running stomach. I don't know. Have you guys ever implemented payment in your career as backend developers? I recently working. I think last year I was working for a startup in Nigeria, and I built the entire self-service payment for their booking system. But let me tell you, even when I finished working on it successfully, okay, my heart would race every time they tell me, "Oh, tomorrow we are going to have a test. We are testing with a user." My heart would race. I don't know if you guys get that anxiety. I would always have anxiety. I had anxiety for a long time. Okay, for a long time, like over a month, for me to relax. Payment. Oh my God, things concerning money. People have eyes on this a lot when you're a developer. Should anything go wrong, they look for fast, even when it's not your fault. So here is the real thing. Oh my God, payment. Trust me. If you've ever implemented payment at your job as a software developer, let me prepare you today. Okay, the day you implement it, even when you review that code, you'll even ask your ancestors to review it for you. You may even want to call your whole family to review that code for you. But after that, even when they tell everybody, when yourself, you think it works, your team says it works, your ancestors have confirmed that it works, and they tell you tomorrow at 9 p.m. we shall be testing this with the user. You'll feel it. Anyway, let me not scare you, but that was my experience. Rima says it works well. I am not sure about local mobile money integration. It's okay. I'll search more about that. I'll search more about that. Yeah, but just know things concerning money, they're not easy. That one I can testify. In fact, one time, the AWS cost for this Django application became increased, and the first person they asked was me. Man, what is happening? Our AWS bill has just increased suddenly. I'm like, how can I start now explaining this? I just knew how to integrate EC2, I deployed on EC2. I was using AWS RDS. I was also using S3, okay? But to understand how costs happen, I was lost, okay? And I had now to be forced to learn certain things. Anyway, enough of that, okay? So yeah, I think we're done with that. Okay, the payment service, ideally integrating the APIs and handling success and failure. Excuse me. Then the other one we need is of course, the ticketing. Okay, implementing things like ticketing, so easy. Okay, not like easy, but there's really no pressure. But when it comes to money, That's why I respect developers who work in banks. Okay, I really respect them. Not because like they write the most complicated code, okay, but the kind of sensitivity, okay, they deal with is very it's very tough. Okay, I had a friend of mine last year went to prison. Okay, they were working on an application which is like a mobile money aggregator. Okay, and I can tell you he was not guilty of anything. Okay, but they discovered he was not guilty after like a year. Can you imagine? But he had been in prison for some time. And the person who was actually guilty was outside chilling, but they arrested the developer. So I think this will be the last service. Others maybe we shall need to talk about them later, okay? Because there are things I need to talk about in details, especially in the component design, okay? So in the ticketing service, okay, of course we just need to generate, okay? Generate and store tickets, okay? Generate and store tickets, okay? That's the main thing, okay? And of course, for you who, if you've ever flown before, we shall track the tickets by their what they call the PNR, okay? The PNR. If I Google for PNR in full, PNR in flights, okay, in flight ticket, you see, a passenger name record, okay, a unique 6-character alphanumeric code that identifies a specific flight booking. So it is unique, okay? The PNR is what we shall be. Yeah, and of course the ticketing needs to do things like sending emails. Even by the all these like booking service needs to handle sending emails, okay? So ideally we might need to have maybe something like, I don't know, mailing or notification service, okay? This is something I forgot, okay? We need to send emails, okay? Email slash SMS, okay? Okay, etc. And of course, ideally in all these things we need to handle, even like in booking service, we need to handle things like failures, okay? etc. So we shall see how that happens, okay? So what I'm going to talk about next, okay? Of course, I see when I talked about the high level architecture, okay, like in the database, there's certain things that should happen, okay. Like for example, concerning okay, let's talk about the database design, okay. Let's talk about the database design. So again, if you're just joining, we're talking about the functional requirements and non-functional requirements. We went to the high level architecture, okay. We went to the component design. We talked about the search service, the seat management and inventory, booking service, payment service, ticketing service. And if there are any other, we shall, of course, add and change, okay? So what I want to talk about, which is actually very important, is the database design, okay? What we shall mainly store will be information concerning maybe booking, okay? For Gambo, when you use that API, okay, what 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 was the main function you used it for? Okay, I want to know. So of course, database design, we shall have a number of tables. Okay. Yes, that we need users. Okay. Make use white. Okay. Then we need to talk about the tables. Okay. So let me do in type tables. Okay. Usually we shall need the users table. Okay. Usually, okay. That says bookings. Yes, users and bookings. For the user, ideally shall have, of course, the ID, which will be the primary key. Okay. We shall have the name. Okay. We shall have the email. Okay. Okay. And what else? The phone. Okay. And the password. Okay. So we shall use the email. Okay. And password for authentication. Okay. We need the name because to know who they are. Okay. Like that. So this is for the tables. Okay. For the user table. Yes, yeah, it says bookings. Shall need a table to manage bookings. Again, I'm just checking to make sure this is visible. So we need a table to manage bookings. And again, as we build, always remind me about the things, okay? So we will be storing password in DB. Yes, but of course it will be hashed, okay? It will be hashed, okay? So let me put here hash. We shall not store the plain text password, okay? It will be a hash, okay? So I can say hashed password, okay? To be clear. So even here, this will also have an ID, okay? Then we need a user ID, okay? Which will reference the user's table, okay? And this will be a one-to-many relationship, meaning one user can make many bookings, okay? Because for the booking, we need something like the flight ID, okay? But that would mean we need the flight table, okay? So, and it will also be a one-to-many relationship between the flight table and a booking, meaning a record in the flight. Wait, is it a one-to-many or one-to-one? Can a flight have multiple, one particular flight have multiple bookings? Think about it, guys. So we need information like the status, okay, of the booking, okay, things like the price, okay. Yes, Jayad, you're correct. It has to be one-to-one, okay, one-to-one. The price and things like the payment ID. Actually, I've remembered when we were learning about the SQL model, okay, we never got a chance to do relationships. So we shall need to do them, okay, to learn payment ID. Okay. After that, of course, since I put here flight, I need now the flight. Okay. We need the flight. Okay. So for the flight, okay, we need things, of course, like the primary key, which will be the ID. Okay. Then things like the airline. Okay. Airline ID. It has to be included. Okay. We need stuff like the origin. Okay. Wow. Doing this by mouse makes me really want to have a tablet. Okay. We have the origin, we have the destination. Okay. We have things like the departure time. Okay. Then also the arrival time. Okay. The arrival time. So let me see what else. Of course, since we have payment ID in booking, we also need the payments. Okay. So for payments, I'll not type all the fields. Okay. But of course we need like the ID. Okay. We need the ID, which will be the primary key. We need the booking ID. Okay. Which booking have you paid for? We need the status. Maybe let me just put them. Okay. And who can guess what will be the relationship between booking and payment? Okay. I think it will be a one-to-one. Okay. And this is where the real thing is. If we succeed at implementing this is the real thing. Payment, handling things like payment, people's money. Then maybe the status. Okay. Oh, yeah, correct. Yeah, user ID. We want to know who has paid. But I guess maybe since we have payment booking ID here, we can track who that person is by the user ID in the bookings table. I don't know, what do you think about that? Since we have booking ID here, we can use booking ID to find out who the user is in this table. So we can leave out that. Okay. I'm glad that you agree. I don't know what the rest of you think. Then the method. Okay. By the guys, don't fear to type anything in the chat, okay? We are learning, okay? I'm learning, we're also learning, okay? Then maybe we have finally the seats table, okay? Then there are techniques that can be used to improve, okay, the database, okay? One way, like when it has grown, okay, we can, the first technique, let me mention it, is indexes, okay? I would put indexes on the following, okay? And please feel free to tell me what other things you could index on. Okay, I would index on the following things. Okay, I want to put a bit lighter color to this one. I would index the following. Okay, I would have indexes. Okay, on origin. Okay, people will search a lot for origins. Okay, the origin. Okay, does everybody know what an index is? Please let me know. If you don't, I can explain. We shall need an index on the destination. We shall need if I think of even the status, okay? Because so many times you need to know, is it complete? Is it not complete? Okay. And also the method, okay? Things like payment method. You may need indexes on this. Okay. One of the best ways better to learn is by just speaking out your mind. Okay. So this will help us for fast search. Indexing will help us for fast search. Then the other thing the techniques to improve the database design. Okay, for example, things like partitioning. Okay, we can partition the tables. Okay, or do things like sharding. Okay, but that would come in when now things are there's need. Okay, you don't just partition for the sake of partitioning. Okay, okay, neither partition. Okay, or sharding. Okay, actually by partition I mean splitting the tables. Okay, splitting the tables. Well, that would be called, ideally that would be called, can I call it horizontal partitioning? Okay, then sharding, I mean vertical partitioning would be, splitting the tables would be vertical partitioning. Then sharding would be horizontal partitioning, where you put your pieces of you split your database into on physical different machines. Okay. All right. So guys, I think we're almost done. Then we go to just setting up the folder structure, and we call it a day. Okay. So what else can I talk about? We've talked about, I think, the external APIs. Okay. Up here we talked about the external APIs. So if I go back to when we're talking about external APIs, okay, we shall be using Amadeus or even Travelport. Okay. For scalability, okay, shall we have static content? Okay, if possible. Okay, if there is need for that. Okay, then we shall need things like CDNs. Okay. So this is about, I've remembered something. Okay, I've remembered something. So for scalability, okay, I remembered a very important tool. It's called Kafka. Okay, remember we shall be having notifications. Okay, so to help us with async processes. Okay, async processes, we're going to do Kafka. Remember what we discussed about async when we were talking about in the first or second live stream last month. Okay, shall use Kafka. Okay, for async processes. Okay, this will help us for notifications. Okay, and there's something actually I've forgotten. Okay, remember logs. We need logs, guys. I don't know how I didn't talk about a logging service. Okay, but we need logs. So for notifications and logs, okay, we shall use Kafka. Okay. Someone says, sir, please explain in brief about indexing and how we decide on what to add indexing. All right, I'm going to come to that. Let's just finish scalability. Okay. Then I talked about, of course, for scalability and performance, we need things like sharding. I talked about sharding. Okay. Sharding will help us. Sharding. Okay. And I'm going to explain what Kafka is used for in a moment. Okay. We shall use sharding. And then for, of course, things like horizontal scaling, we shall use Kubernetes. Okay. And actually, this is something I'm going to, okay, Kubernetes, let me say, ideally plus load balancer. Okay. Okay. So Kubernetes will help us with this, okay? And of course, even Redis, okay? Remember I talked about Redis up there. Redis also will help us, okay? For scalability. Okay, this should be ideally named scalability and performance, okay? These are the tools that will help us. So I'm going to start by explaining Kafka, okay? What is Kafka, okay? If I come here and I simply Google Kafka, they say Apache Kafka is a distributed streaming platform and used for building real-time data pipelines and streaming applications, okay? So they say Kafka is an event streaming platform used by thousands of companies. So let me just explain it, okay? So let us say, for example, someone wants to maybe to book, okay? Okay, someone wants to book, okay? And after they have done booking, okay, when they're booking, ideally what we'll do, we can make a transaction in our database, okay? After that, we can make another transaction in, for example, we notify them, okay? Send a notification, okay? By email, okay? It can be by email or it can be by SMS, okay? But then, okay, this is like synchronous, okay? Database has to happen, then after that, email, then after that, SMS, then finally, we give the person a response, okay? So they're happening in order. Database recorded, notification by email, notification by SMS, then we tell them a response, okay? So ideally, they cannot get a response if the email and SMS is not sent, okay? And then we also have logs, okay? Then maybe after sending the SMS, we log, okay? We make a transaction that this has happened, okay? So database record is saved, booking is saved, email must be sent, then SMS must be sent, then login must be sent, then we give the user a response. That is a long running process, okay? And sometimes things like SMS which use SMTP can be very slow, okay? They can be very, very slow. And this will be a bad experience for our users, okay? So what can happen is this, okay? We 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 save it in the database, okay? This is another flow, okay? We save the information in the database, okay? Ideally, okay? After saving the information in the database, okay? To send, we now send an event, okay? We have an event system, okay? Let me say event system. Say event, okay? We trigger an event saying a booking has happened, send an email, okay? So an event for sending an email, okay, is sent quickly and we leave it, okay? Then another event can be sent for example, SMS, okay? And another event can be sent to the event system for logging, and immediately we return the response to the user that booking is successful, okay? Here, the event system under the hood keeps track that maybe the email is still has not yet been sent. It's maybe taking 2 minutes to be sent. SMS is taking maybe another 5 minutes. Login is taking another what? 3 minutes. Okay. Total time for sending email, SMS, and logging is probably around maybe 3 minutes. Okay, or 5. Okay, but the user does not know that. Okay, for user just sees it happen in a microsecond, okay, and they receive the response saying booking successful, okay. So this event management, this event tool, okay, when the email has successfully been sent, okay, when it can either alert us, okay, or successfully tell the user, okay, that this has successfully happened, okay. One example of that kind of system is Kafka, okay. Kafka. So ideally, it's used for async tasks, okay, whereby you have something that is long running, okay, and you don't want it to block, to delay your execution of your endpoints. So you can let that to be happen by things like Kafka, okay, and when that stuff which is long running is complete, Kafka can tell you that what's the best word? Can let you know that, okay, this long running task has successfully finished. Okay, so you'll hear about things like subscriber and whatever. Okay, so you subscribe to Kafka to tell you that A, B, and C has completed. Okay, and is now working. Okay, this is the next question. You've teased my, they said it's one thing to know something, but it's another thing to be able to explain it. Jayat, have I confused you? Have I made you to understand it? And actually when we start building it, you'll understand it in depth. Okay, please let me know whether you've understood or not. So that's Kafka. Then the other question was, how do we decide what is brief about indexing? Okay, so I have a book here I was reading. Where is it? That's what I used last time to explain indexing. Okay, so here's a book. Okay, so this book has a table of contents. Okay, let us look at the table of contents. Okay, I want to find it. Look at where's the table of contents. Here it is. Okay, so a book has table of contents. Okay, like we are saying here, this book is called the Little Common Sense the Little Book of Common Sense Investing. Okay, so if I look at this book, it has, for example, like chapter 14, bonds. Okay, and is on page 167. Okay, if this table of contents was not available, I would have to go page by page, looking for it until from page 1 up to page 167 to find it. That is time wasting, checking page 1, 2, 3, 10, 20, 30, 100 up to 167. Okay, but by looking at the table of contents, okay, I simply go to page 167 directly. Okay, I don't have to search from page 1. I just go to 167 and find that chapter. That is the same way database indexes work. Okay, without a database index, your database would have to search from the first record until that record to find it. Okay, but if there's a call, let me ignore it for now. Sorry for that. Okay, but if there's a database index, okay, it works the same way like an index in a book. Okay, instead of going page by page, okay, the database can quickly find that information. Okay, that is required. That is what a database index is. And you had another question saying, how do we decide on what to add indexing? So you index what is frequently searched for. Okay, like for example, in our case, it will be things like the origin, destination. Okay, information which is uh, frequently searched for is what you should index. Okay, but there's a trade-off on indexing. Okay, don't try to index everything, because if you index everything, okay, you may even instead harm your application. Okay, because now you'll have so many indexes, and that increases again more reading and space. Okay, so you have to be careful on indexing. Okay, I need to handle something here, just a moment. So yeah, please let me know if you've understood what indexing is all about. And if anybody else has a question, please let me know. So don't index everything, okay? Indexing is a process that can actually take up additional storage space. So be careful when you're indexing. Someone is saying, let me just handle this. Just a moment. All right, so let's continue. Yes, I understood completely, and sorry for the interruption. Please proceed with the no. It's okay. It's okay. Okay. Discussions are good. When you ask a question, it forces me, okay, to learn how to explain what I understand. Okay. So it's a very good thing. So next up, maybe what we can talk about is security. Okay. Of course, I know we talked about it up briefly, but we can talk about it again. Just mention the details to be sure to reinforce it. Okay. So for security, we shall use GWT auth. Okay. And lucky for us, we learned about this. Okay. In one of the streams last month. Okay. So let's use JSON Web Tokens for auth. Okay. Then also, of course, we shall have rate limiting. Okay. Like for example, rate limiting is a mechanism that allows you to specify how often someone can execute your endpoints. Okay. Okay. Sure. We need rate limiting. Okay. And of course, we need secure payment. Okay. Secure payment, and depending on the payment gateway, we might need maybe to enforce extra things. Okay, like tokens. Okay, it should only happen via HTTPS. Okay. And of course, we need to be careful with people data. Okay, like hashing passwords and okay, stuff like that. Okay. What else? Maybe finally. Okay, not finally. A few things. Then we go to the actual code base to structure it. We need monitoring and logging. Okay, that's very good. After developing your API, you need to know what is going on. Okay, this could be part of actually the DevOps work. Okay, we shall go into things. Actually, there's going to be a lot of DevOps in this. Okay, so we need to talk about monitoring and logging. So for monitoring and logging, we shall use something like Prometheus. Okay, so I've never used it, but I just searched. Okay, so we shall learn together. So there's when I searched, they said you can use a tool called Prometheus and another one called Grafana for metrics. So we shall learn how to use these live. Shall use Prometheus plus Grafana for metrics. Okay. Then remember I talked about logs. Okay. We need to use a tool called Datadog. Okay. At least I've used this before. Those of you some of you who have here did the ALX 12-month program. Okay. You remember Datadog. Okay. Something I've heard about, is it ELK? I hope it's the correct. Yeah. For logs. Then we need alerts. Okay. Yeah, we just need alerts. Okay. Alerting for things like latency. Okay. When things are slow. So you shall have like thresholds. Okay. And the things, if the things go below or above a certain threshold, we need alerts. Okay. For latency, for when bookings fail. Okay. Failed bookings. Okay. Failed payments. Okay. Failed bookings. We need alerts for this. Okay. Then we also need for alerts for dropped payments. Dropped payment. Wow, this stream has taken long. I don't know how. Let me see the time. Wow, it's taking some time. Okay. Interesting. Okay. The final thing before now we go, it will be, let me see. Are there some advanced edge cases if you can think about? Okay. I think we can handle them later. Okay. Let's go to now the actual project setup. Okay. So to do that, I just need to access my terminal. Why is it refusing? Okay. come here. I hope you can all see my terminal. CD projects. I don't know how many projects I have here. Yes, Kibana for Elasticsearch. So I'm looking for something. Okay, so I'll open this in VS Code. This is the actual project. Okay. I hope, let me just refresh this to make sure you are seeing the right screen. Okay, I've confirmed that you are actually seeing the correct screen. Okay, so if you're enjoying this, guys, please share, okay, so that people learn about this, okay. Subscribe to the channel so that we grow, okay. So I'll close this. Okay, so like you can see, I have the front end, okay. I have some of the front end. I'll show you the front end when it shall be, when the front end, when we shall be consuming the API, okay. I plan to have a mobile app, okay, and the things shared, okay. But the backend, you see, the backend only has a README, okay, but empty. So I'm going to open up a terminal and create the basic structure. So last week when we were learning about, okay, when we were learning FastAPI, there's a basic structure. So if I can go to FastAPI docs, okay. For those of you who learned with me, if you remember, if I go to, what was that, learn tutorial user guide, there's a topic somewhere. Where was it? Somewhere down. This one here, bigger applications, multiple files. Remember it? This was the app structure, okay? So they're saying, you see, if you're building an application or web API, it's rarely the case you can put everything in a single file, okay? We shall not have everything in a single file, okay? They're saying FastAPI provides a convenience tool to structure your application while keeping all the flexibility, okay? So this can be an example, okay? We can start something with something like this, okay? Then we change, okay? And we're going to Google the best, because like, you know, I learned FastAPI with you live. I don't know how people structure their FastAPI applications, okay? So we're going to learn together. But to create my project, okay, there's a tool I want to use, okay. I don't want to do pip install, okay. I don't want to do pip things here, okay. There's a thing I want to use, okay. I don't know if you guys have heard about it. It's called UV Python. Have you guys heard about UV? Please let me know. In the Stack Overflow survey that came out recently, it's one of the most loved tools, okay. UV, let me make this bigger so that you can read, okay. If you come here, okay, they say an extremely fast Python package manager and an extremely fast Python package and project manager written in Rust. It's what I'm going to use to set up the project, okay. So you see, it is faster than Poetry, PDM by, yeah. Previously I was using Poetry, okay. Then since I heard from you, I have tried using it and it's very fast. Oh, that's nice. Yes, built in Rust. So I guess I should be having it. So this, if you don't have it, this is how you install it, okay? Copy this and run it on your machine. If you're on Mac OS and Linux, okay? On Windows, execute this, okay? But me, I already have it, okay? Or you can install it from PyPy like this. But this is documentation. So this is how you start, okay? So UV init example, okay? So I'm going to go to that project directory. I want to cd backend, okay? And then I'll say UV init. I don't know if I put a period. I don't know if it will create in this current. It has done what I wanted. Yes. So you see we have a Python version 3.5. We have main.py. Okay. Saying hello from backend. If name equals to main, execute that. Okay. Then there's the PyProject.tomo. Okay. For managing our dependencies. Okay. Which is good. Okay. So after that, I can say UV add to add a particular dependency. Like in our case, we want to work with FastAPI, okay? I'll say uv add FastAPI. But this way of installing, I want to go to FastAPI docs. Actually, the docs are already open. There's something I want to see. First steps, okay? If I scroll, I hope it can be installed using UV. Otherwise, we shall be I will be disappointed, okay? Before the first steps, there should be something like install. Let me say pip. There's no pip on this page. Tutorial user guide. I'm looking for the part where they have like what? Installation. Because remember last time when I was installing it, I made a mistake, okay? This way you're supposed to install it by saying is it FastAPI standard or something. Let me just search install. Aha, here it is. You see, FastAPI standard installation. Okay, they say pip install FastAPI standard, not FastAPI. Okay, so the same way I will go here. Okay, and I'll say uv add FastAPI. Okay, so this tool called uv should create a virtual environment. Okay, for us. Okay, that's the good thing I like about it. So let us hit enter and we see. Look at it. So it is installing FastAPI. And look at this. We have a .venv here. Okay. So yeah, very cool. Lena says, I heard from you. I have tried using it and it's very fast. That's good. Gimba says built in Rust. That is true. Lena says, go to virtual environments in documentation. They have it. Oh, but I guess I already saw it. Let me go to documentation, and I go to virtual environments. Create a project. Okay. Thank you, Linus. If you remember that I ignored this part, okay? But here it is using UV, okay? So if you have UV installed, you can use to create a virtual environment, okay? So we are good. So there we are, okay? We have everything, okay? So far, going well. Listen, now we need to set up the project structure, okay? I'll delete this. If we need it, in fact, we shall always come back to the documentation. Once in a while, we are going to be using AI and yeah. So they say to run it, you say uv run. For example, if I want to run this file, I say uv run main.py. Okay, and so we get hello from the backend. It's pretty fast. Okay, then after that, I need to Google something. Okay, FastAPI project structure. Okay, this is something you can always change. Actually, why did I close the docs? Okay, I shouldn't have closed the docs. So what I want to do is to go back to where is that part that we had. Okay, and those who are just joining right now, we finished the whole system design, okay? The main part of it. Okay, we went through the requirements, the high level architecture, went to the component design. You can just go back and watch everything. Okay, and of course we shall be iterating as time goes on. So FastAPI, these are videos, full stack FastAPI templates. No, I don't want FastAPI. Beginner question, we shall need that. How to structure your projects. So we need to learn from multiple sources, okay? But I want to start with this one, okay? Wait, I didn't even click on it. This is what I want, okay? So what I'm going to do, so we have app, okay? In our case, app is this folder, backend, okay? Then after that, we need an init.py file. It has to be a package, okay? So because I'm lazy, I'll just copy this, okay? So this has to be a package, okay? Then we have the main.py. We need a file for dependencies, okay? All dependencies will live here, okay? If you don't know what a dependency is, please watch the live stream on dependencies, okay? Then after that, we need routers. So I'll create a package for routers. I'll copy this and put an init.py in file there. We need, of course, we shall have things like users, okay? ideally we shall have like a router for users, okay? We shall have, for example, for bookings, okay? Bookings.py. We shall have for payment, okay? Payments. Well, help me know. Would you name it bookings or booking or bookings? Would you name it payment or payments? Would you name it users or user? Let me know in the chat. Okay, so what else do we have? I guess others we shall add, maybe things like maybe flights, okay, flights.py, okay, tickets.py. So routers for all this, okay. Then things like maybe internal tools, okay, we could have this later, by the way, very important to have, okay. Internal, I'll copy this init.py inside this to make it a package, okay. Then inside here we can have basic main.py and we can add, okay. So routers, in addition to that, we could need things like okay, since I'm done with this setup, I want to see what other people say, okay. So look at this article, they say how to structure your FastAPI projects, and here they have 800 claps, so probably it's a very good one, okay. He explains why proper structuring matters, but of course we know it helps with scalability, maintainability, and collaboration. We shall keep on changing, okay. Wow, so look at this, okay. Look at this structure. Isn't this interesting? So this is the main app. This is the app, okay. We have this, okay. Let me expand it so that you can see it easily. Let me just confirm here to make sure you can actually see this properly. Okay. So yeah, it should be now visible. So Lena says I would use plural as they are handling many. Okay, that's good to know. So we have our app. For us, this is backend. Okay. We have the init. Okay. Which is this. So we shall follow his. In case of anything, we shall always change. Okay, since we are learning. Let me close all these. Okay. Then we have dependencies. Okay. Defines dependencies used by routers, which is this one. Okay. Which we have created. After that, he has routers. Okay. We have this kind of stuff. Okay. This one says define routes and endpoints related to users, define routes and endpoints related to items. So in our case here, this one, all bookings will define routes related to bookings, flights, routes related to flights, payments, routes related to payments, tickets, routes related to tickets, user and etc. We shall add as required and modified where necessary. After that, he has CRUD, okay? So it says define CRUD operations for items, define CRUD operations for users, okay? So in the same way, okay, we need CRUD operations for bookings, flights, payments, tickets, users. So I can simply copy this, okay? Copy and paste and I can just simply duplicate it, okay? Then I come here and rename it to CRUD like that, okay? So this is our current structure, okay? Then you have schemas, okay? Schemas for everything else, okay? So we need, so I'll copy and paste CRUD, rename it to schemas. So we learned about schemas. If you don't know what schemas are, again, watch my playlist, okay? Watch the place where we learned about it. In the playlist, in one of the playlists, if I go to YouTube quickly, okay? And go to playlists, okay? Not this one. Go to playlists. I'm instead seeing myself, okay? I come to the channel. I need to cancel this. There's this playlist, okay? So there's a video where we did search for it, okay? And watch about schemas or everything else concerning the FastAPI. So in the same way, we need schemas for every entity for bookings, flights, payments, tickets, users, okay? Then after that, we need models. Remember, we learned about models, okay? So I can simply, for example, copy this one, duplicate it, rename it to models. Come on, where's rename? models. Okay. Who can tell the difference between schema and models? Then external services. Okay. Things like, you see, like they say, sending emails, notifications. Okay. Payment. Okay. This is external, what external services will help us with. Okay. So I can duplicate models. Just copy this name. Okay. Then come here and rename this to external services. So for external services, we need, for example, like for sending emails. Okay. How do they name it here? Is it email? Okay, it's email. Okay. Come here, email.py. Okay. We need something like phone. Can we? Should it be in external? Okay. Let me say payment. Okay. Payment. Okay. Let me delete this. Okay. Maybe things like Amadeus. Okay. Amadeus. Again, if it's not the right place to put it, I'll remove. Then I can delete these other things like payment, tickets, users. Okay. We don't need them. Delete this. Even flights we don't need. Flight book. It looks like I've did something important. This shows I'm getting tired. Okay. So ideally, here external services. Okay. We need one for payment, payment.py. Okay. We need for, okay, let me say for flights. It may not be Amadeus. It could change to another something else. Okay. But a service, an external service to help us with flights. Okay, is what we are going to need. What else? We shall need utilities. Okay, like for authentication, functions to help us with validation. Okay, so important. I'm guessing any of you who has done development, you've come across a folder or a directory called utils somewhere in your project. Okay, utils, and I'll copy utils. We shall have something concerning like validation. This is obvious. Okay, we need a utility to help us with authentication. In case we need, we shall create it. You don't have to create all of them. Then of course tests. Okay. Another module. Okay, ideally in backend, code tests. Okay. So of course, just copy this. I should have just duplicated. Okay. So you need .py. Okay. And of course, we need like tests for everything. Okay. Tests, for example, like for bookings, tests for flights, tests for payment, tests for this. Okay. I'll come here and copy them and paste them into this tests folder. Okay. But ideally, you see how they're named? Test this, test, they're prefixed with test. Okay. So I have to come here and prefix each of these. I say rename, say test underscore booking. Because we're going to use a tool called PyTest. Okay. Test underscore payments. Okay. Then here we rename to test underscore flights.py. Okay. So for everything, we shall have like a test file to test that particular set of features. Okay. Or service. So let me just expand this. Okay. So you can see the structure better. So that is it. We have CRUD, external services, internal, models, routers, schemas, tests, utilities. Okay. Yeah, that is it. What else? If I come back here, they have requirements of text, but we don't need that, okay? Because we are dealing with UV, okay? It has its own way of managing. It has this UV lock, PyProject, and this Python version thing, okay? Git ignore, okay? What do we need? I think there's a git ignore somewhere, okay? Because I'm seeing .env has been ignored. So where do I have it? I guess this frontend directory has it. Okay, we can add for the backend separately. Okay, it won't hurt. But I'm starting to wonder, what can we ignore? Because it looks like the .env has already been ignored. What am I doing? This is the wrong directory. It's supposed to be here. Okay, create a file, .ignore like that. Okay, and for example, we have a .env like that. Okay, if I do a git status, okay? And you see the changes, okay? So far we see git ignore this, init.py, that, okay? I don't think there's a secret. In a secret file, we don't need to push. Please let me know. Guys, I know this has been long, a long stream. You must be tired. Let me just do this just a moment. Okay. What else? If I come back here, okay. Yeah, so here he just explains what each of them does, okay. So it's going, and yeah, if you don't understand them as we build, I would be explaining to you, okay. Then they have this kind of stuff, okay. See AWS, we might even have something like this, okay. Yeah, but we shall change where necessary. And actually, I want to make sure later I read this so that when we are doing the actual thing, it makes sense. Okay. Yeah. So friends, that is it for today. We have learned, not learned, so that we have discussed. Okay. The system design. We have set up the project. Okay. All I need is just to now push this to GitHub. Okay. And I'll do that maybe after. I just need maybe to go through it, make sure I've not forgotten any secret file. Okay. But that is it. Okay. In the next stream, we're now going to start building. Okay. Probably I'll need to use maybe AI to help me with the user stories. Okay. Then we're going to start implementing user story. Okay, by user story. Okay. So we are going to start building feature by feature. So we shall start, for example, like we shall start with authentication. Okay. Authentication, we deal with sign up. Okay. We deal with things like maybe even forget password. Okay. Getting current user, protected routes, stuff like that. Or we can even start with flights, because actually for the application to start working, you don't need authentication. Okay. You need searching of flights. So we can actually start with searching of flights and we understand it. Okay. And of course, we can use AI to help us, but of course, we shall have to review the AI code. Okay. And if reviewing AI code takes forever, I'll rubbish it, okay, and write the code from scratch by myself, okay. Yeah, so we're going to do that. I think she'll start with maybe flights and maybe authentication and stuff like that, okay, just like we have had. Lena says schemas validate what requests the server expect and the response it gives. Models define what they store in the database. Okay, I think you answered the question when I asked the difference between models and schemas. But according to the guy who defined that structure, he says the schema is where it will store the Pindatic schema. Okay. Yeah, but actually your use case also matters. So thanks everybody for showing up today. Okay. We are done with this planning and design. In case of anything, we shall always iterate. Okay. We shall always iterate, make changes, improve, break, build if necessary. Okay. So please have a good rest of your evening, morning, afternoon, or night. Okay. And catch you in next stream. Okay. So the next stream, I think probably we do Monday if possible. Okay. If not, maybe tomorrow. So watch out for either a stream tomorrow at the same time. Okay. Or Monday. Yeah. Tomorrow I'm not sure because I have a conflicting schedule. Okay. Which may make me to travel far and I may fail to come back here in time. Okay. But yeah, subscribe if you've not. Share this with others. Okay. You may find out the people pay for us to have this kind of discussion. Okay. So if you know that some person can learn this for free on YouTube, that's why I like YouTube. If you know people who can learn this for free, share with them. Okay. Subscribe and yeah, let's grow a community together. So I hope you've learned something. Personally, this has helped me to refine certain things in my mind. Okay. They're now deeper and I've loved all your contributions. You've made me think out loud and be able to explain what I understand, and I'm even going to do more research, okay, so that I am more equipped. So thank you. In the next session, we are now going to start the actual building. But remember, the building is only successful if we have a good plan like this, okay? So as we build, we shall see what to refine, what to change, what to improve. So yeah, bye for now and catch you in the next stream, okay? Either tomorrow, same time, or if not possible, Monday. But Monday is assured, okay? So ideally, Monday to Friday is assured a stream at 9 p.m., okay, until we finish building this application, okay? But tomorrow, Saturday, it's just watch out, okay, for a notification. So you can hit the bell to be able to be notified about that. So tomorrow we can have the first implementation of the first feature, or Monday. All right. So yeah, Ogembo, Linus, Giant, thank you for being active participants. And everybody, even if you did not participate in the chat, thank you for watching. Let's learn and build in the next video. And of course, share this with everybody else that you think can benefit from this. Bye for now.